Bonjour les élèves et bonjour tout le monde. C'est la 23e vidéo du playlist Physics O-Level, syllabus 50-54, et dans sa vidéo-là, on va résoudre quelques questions de multiple choice sur le sujet de Kinetic Particle Model of Matter ou bien Kinetic Theory of Matter. C'est une question de Cambridge, d'examen. OK? Et là, moi, je vais le questionnaire. Et nous avons 46 questions. Et il y en a nous un temps de 55 minutes pour terminer ces 46 questions. Bon, a gas in a container of fixed volume is heated. What happens to the molecules of the gas? They collide less frequently, Monty. They expand. Fixed volume cannot expand. They move faster. Oui, they move faster. Okay. They move further apart. They are in a fixed volume. Comment on est capable de move further apart? Pas gain droit. OK. Ça veut dire C, c'est la réponse. The diagram shows the inside of a refrigerator and cooling unit là-haut. When the refrigerator is first switched on, what happened to the air near the cooling unit? Bon. Parce que il fait cool, the particle of this air will become smaller. No, particle will become smaller. Okay, they move closer together. Ça dit là bon. Et what the density of the air? Parce que if they move closer together, the density will increase. Okay, D c'est la réponse. Which diagram represents the change in the arrangement of molecules in a solid as the substance melt? Okay, et ça non? Ça non, et orderly arrangement, okay, to random arrangement, but it's still packed together. Ça, c'est from solid to liquid. Some gas is trapped in a closed container. The gas is cooled and the volume of the container is kept constant. Okay, what happened to the gas molecule? They cannot collide with the walls more often because coolly the kinetic energy will decrease. Okay, they contract. What happens to the no? They can't contract. They get closer together. Et non, parce que they are in a fixed volume. They are still a gas. Okay, they move more slowly. Ça c'est la réponse. Et in a liquid, some energetic molecules break free from the surface even when the liquid is too cold for bubbles to form. In a liquid, some energetic molecules break free from the surface even when the liquid is too cold for bubbles to form. Ça veut dire, l'IPAP est boiling, mais the molecules are escaping from the liquid form, even vapor form. Comment on appelle ça? On appelle ça evaporation. A gas is a sealed container of constant volume. Is in a sealed container of constant volume. Okay, the gas is heated and the pressure of the gas on the wall of the container increases. How do the particles of the gas cause this increase in pressure? And they hit the container more frequently because they are moving at higher speed due to the increase in kinetic energy, due to increase in the temperature. Okay, the gas is heated, et là, basically heat more frequently, et là, the pressure will increase. Some of the liquid in a dish evaporate as shown in the diagram. Before evaporation, after evaporation. Which molecules leave the liquid and which molecules in the liquid have greater average kinetic energy? Molecules that leave have high energy. Définitivement. Molecules in the liquid have greater average kinetic energy. Before evaporation, after evaporation. Définitivement, after evaporation, it becomes gas and they will have a greater kinetic energy. Ça, c'est la réponse. Okay. Et qui fait that they have greater kinetic energy because they are not held by the strong forces in the liquid, the attractive forces. A piston is supported by gas trapped in a cylinder. Okay? No matter weight là, the volume is decreased. Okay? The volume of the gas supporting the piston decreases, but the temperature of the gas remains unchanged. Okay. What happened to the molecule? They hit the piston, that is the piston, more frequently. They move more slowly. They have a smaller size, ça mentit ça, hein? They have more kinetic energy. OK. Normalement, nous besoin connaître sa formule-là, P1 est égal à P2, P2. OK? Et puisque nous decrease the pressure the volume is decreased. Ça veut dire the pressure has increased. The pressure has increased, but the temperature remains constant. Ça veut dire que pas capable de have more kinetic energy, but they hit the piston more frequently. Qui fait parce que il n'y a plus beaucoup de molécules in a smaller volume. OK? Ça veut dire ça, c'est la réponse. Ça a menti. Numéro 9, the diagram shows a flask containing air. The air is trapped by a drop of oil in a narrow tube. When the flask is heated, the oil drop rises up to the tube, which statement is not correct. The air molecules get larger. Ça n'est pas normal. Ça. Air molecules reste air molecules. Pour moi, ça n'est pas correct. Enfin, ça c'est la réponse. The air molecule hits the container with greater force. Ça a livré. The air molecule move faster, livré. The air molecule move further apart. Ça aussi livré parce que le volume est increased. Ça, c'est la réponse. 10. Water is poured in 4 dishes. In 2 of the dishes, the water has a small surface area. And in the other 2, it has a large surface area. The water in 2 of the dishes is cool. And the water in the other 2 is warm. From which dish does the water evaporate the quickest? Bon, on a 4 dishes. Un dish, 2 dishes, 3 dishes, 4 dishes. Okay. One is small surface area, small area, small area. That's a big area, that's a big area. Okay. The water in 2 of the dishes is cool. And the water in the other 2 is warm. Okay. Et il n'est pas dit à nous. Il n'est pas dit à nous, c'est pas the 2 of the dishes with the small surface area ou bien large surface area. Il n'est pas dit à nous. Okay. From which dish does the water evaporate the quickest? Okay. Bon. Quand the surface area is large et the temperature is warm, the water will evaporate the quickest. B, c'est la réponse. At constant temperature, a solid has a fixed shape and a fixed volume. Okay? Which row describes the shape and the volume of a liquid at constant temperature? At a constant temperature, a solid has a fixed shape and a fixed volume. Which row describes the shape and the volume of a liquid at constant temperature? Because liquid, hein? Shape not fixed. Volume fixed. C'est la réponse. When a gas in a container of fixed volume is heated, the pressure of the gas increases. Okay. When a gas in a container of fixed volume is heated, the pressure of the gas increases. Which statement explains this? The molecule expands and gets heavier. Ça mentit, hein? The molecule have less room to move, so they collide with each other more frequently. Fixed volume. Mentit. The molecule hits the wall harder and less frequently. No. Hit the wall harder, oui, more frequently. The molecule move faster, so they collide with the wall more frequently. Ça, c'est la réponse. What happens to the molecule of a gas when the gas changes into a liquid? They move closer and lose energy. Ça paraît correct. They move closer, no. They move apart and lose energy, no. They move apart and gain energy, no. OK. Pour moi, ça, c'est la réponse. OK. Et qui fait moi vérifier tout ça là, parce que, attention, moi, je fais une erreur, après, nous devons vérifier, nous éliminons toute réponse qui est possible. Hein? On élimine toute réponse qui n'est pas bon, pas qui est possible, qui n'est pas bon. When a person climbs out of a warm swimming pool on a hot summer day, he feels cold. Why does this happen? Out of a warm swimming pool on a hot summer day, he feels cold. Okay. The air has a specific heat capacity. The air is a better conductor of heat than water. The water droplets increase his surface area. The water takes heat from his body to evaporate. Et là, la réponse est ça. Hein? Okay. The water takes heat from his body to evaporate. Ça veut dire, quand il peut évaporer, il prend une quantité d'énergie, ça veut dire qu'il prend le heat, et du moment qu'il prend heat of the person a less energy, he will feel cold. Which row correctly describes the shape and volume of a gas? Shape not fixed, volume not fixed. Okay. A fixed mass of gas is kept at constant temperature. Its temperature is raised. What happens to the volume of the gas and to its molecule? So constant pressure, fixed mass of gas, temperature is raised. OK? Ça veut dire nous connaissons que volume is proportional to temperature. You raise the temperature, the volume will increase. Parce que pressure is constant. Volume increases, molecules move further apart. Voilà. Air is heated in a sealed container with constant volume. Why does the air pressure increase when the temperature increases? Bon, et the air molecule bounce off the wall more frequently. It will increase the kinetic energy. Okay, constant volume, temperature increase, increase the kinetic energy. The air molecule bounce off the wall more frequently. The more energetic molecules in a liquid may escape from its top surface. What is the process called? Evaporation. A gas is enclosed in a container of fixed volume. It gains heat energy from an external source. A gas is enclosed in a container of fixed volume. It gains heat energy from an external source. What happens to the molecule of the gas? They move faster inside the container. Là, they cannot expand fixed volume. They cannot move further apart fixed volume. They vibrate with greater frequency et mandassa. Et bien sûr, in a vibration, mais tellement de move faster. The kinetic energy will increase. A fixed mass of gas is enclosed in a cylinder by a movable piston. Okay? The piston is moved so that the volume occupied by the gas increases. The temperature remains constant. Okay, what happens to the pressure of the gas and why does this happen? Volume occupied by the gas increases. Ça vient de quelque chose qu'on a vu ici. Ça veut dire pressure pour decrease. Ça veut dire là-dedans. Reason, the molecule move more slowly. The molecule collide with the piston less frequently. Temperature remains constant. Okay. Temperature remains constant, et là, the pressure will decrease. Qui fait? Bon, the temperature remains constant, ça veut dire the kinetic energy of the gas will remain the same, mais puisque nous n'avons plus de volume, they have to travel longer distances, ça veut dire, je pas pour capable collide so frequently with the wall, ça veut dire, nous dire que the molecule collide with the piston less frequently. Là, B, c'est la réponse. A substance has a melting point of negative 17 degrees Celsius and a boiling point of 117 degrees Celsius. In which state does the substance exist at negative 10 degrees and at 110 degrees? The melting point at 100. Okay? Ça veut dire, below ça, it is solid. Là, entre ça et ça, il est liquide. OK? Ça veut dire les deux sont bien liquides. À négatif 10 degrés, ça veut dire nous rajoutons 7 degrés, alors il est négatif 10 degrés. Nous retirons 7 degrés, il est 110 degrés. Les deux bien liquides. Ça, c'est la réponse. When a gas is rapidly compressed to a smaller volume, its temperature increases. What happens to the gas molecules? When a gas is rapidly compressed to a smaller volume, the temperature increases. What happens to the gas molecule? Et là, they move closer together and their average speed decreases. No, si temperature peut increase, average speed pas capable de decrease, average speed bisa increase. OK? Ça veut dire ça monte, ça monte. OK? Nous découvrons là, nous découvrons là. OK? They stay the same distance apart. No, the volume is decreasing, they will move closer together and their average speed will increase. C'est bien la réponse. On a hot day, the drink in a bottle can be kept cool by standing the bottle in a bowl of water and placing a wet cloth over it. Okay. Why is the drink kept cool? Hot air cannot escape from the bottle. The cloth conduct heat from the bottle into the water. The drink cannot evaporate from the bottle. Water evaporating from the cloth cools the drink. Ça, pareil, avec les raisonner, on va dire, you know, water là. OK? Quand il peut évaporer là, il peut take some heat là. OK? Et quand il peut take some heat là, ça veut dire, ça air là, il peut cool là, finalement, ça bouteille là. Il peut rester à une température un peu froide. OK? Et nous allons dire ça, the water evaporating from the cloth cools the drink. Hot air cannot escape from the bottle. Ça, il est nonsense. The cloth conduct heat from the bottle to the water. No. No. Okay? The drink cannot evaporate from the bottle. Non, le drink là, il permet là, il peut évaporer. Ça, c'est la réponse. D, c'est la réponse. Water evaporating from the cloth cools the drink. According to the kinetic theory, matter is made up of very small particles in a constant state of motion. Okay. Which rule best describe the particle behavior in liquid state? Forces between particles is wrong. Motion of particle move randomly at high speed, vibrate but are free to move. Vibrate but are free to move position, vibrate to and fro around. No, ça mentit. Okay. Move randomly at high speed là, et vibrate but are free to move position. C'est quoi? Moi, je vais trop compliqué, ça anglais la même. Vibrate but are free to move position. OK? Move randomly at high speed. Bon, ça, c'est plus, comment dire, gaz. Gas move randomly at high speed. They vibrate but are free to move position. Et là, moins peu, en doute moi-même là, hein? Moins peu en doute moi-même. Bon. Et parce que randomly, quand on fait cause high speed, et nous bien fini comprendre que ça, c'est related to gas. OK? Et nous pouvons dire que it vibrate, yes, but they are free to move the position inside the liquid. Ça veut dire pour moi, là, on prend B comme la bonne réponse. OK? Je ne suis pas trop d'accord avec sa phrase-là, mais je trouve que la réponse c'est B. A balloon filled with air is gently heated. What happens to the mass and the density of the air inside the balloon? Okay. The mass will remain the same. So, A balloon filled with air is gently heated. The density est pour decrease ou bien pour increase. Pour esparer, vous pensez, hein? OK? Non, vous faites rien là. OK? Et parce que le balloon, the air inside is heated gently. Parce que the balloon, the wall of the balloon, the enclosure of the balloon, the surface of the balloon, c'est pas une fixe, c'est pas rigide, OK? Et là, the balloon will expand. Du moment que the balloon will expand, the density will decrease. OK? Et ça, c'est la règle. Which row explain why a liquid has a fixed volume but does not have a fixed shape? Forces between molecules in a liquid is large. Movement of molecules in the liquid moves throughout the liquid. Okay. Fixed volume, but no fixed shape. Okay, volume, fixed volume, no. Yes. Fixed volume, ça peut fixer le volume. Ça peut faire une shape being not fixed. No, not fixed. Okay. Bien, no fixed shape. The liquid in a puddle evaporates and this causes the temperature to change. How does the temperature of the liquid change and why? The temperature will decrease. Parce que quand il peut évaporer, il peut prendre une énergie et puis the liquid, il peut aller. Reason? More energetic molecules leave the liquid. A liquid evaporates rapidly. Why does this cause it to cool? Même d'après qu'il a là. A molecule will move it by contact with the liquid surface. Energy is lost by convection current. Some of the most energetic molecules leave the liquid. C'est ça. The liquid, there are less internal energy, avec the other temperature decreases. What happens when a metal ball is heated? The distance between the molecules increases, making the ball longer. The molecules get larger. The molecule get larger. Vibrate more quickly, making the ball denser. No, the ball cannot become denser. The speed of the molecule increases, making the ball thinner. No. The distance between the molecule increases, making the ball longer. The ball expands. Il fait parce qu'il peut vibrate with greater amplitude. Okay? Du moment qu'il vibrate with greater amplitude, the distance between the molecule increases. Therefore, the ball becomes longer, larger, wider, etc. Ça, c'est la réponse. A fixed mass of gas at constant temperature is compressed to reduce its volume. A fixed mass of gas at constant temperature is compressed to reduce its volume. How does the molecule of the gas now strike the walls of the container? Compress, ça veut dire less often. No, it becomes more often. Same amount of molecule in a less volume, more often. More often, but with the same velocity, constant temperature. Velocity depends on temperature. A quantity of gas is trapped in a container by pistons exerting a force F. The temperature of the gas is raised while F remains unchanged. Okay. A quantity of gas is trapped in a container by a piston exerting a force F. The temperature of the gas is raised while F remains constant. Okay. Which statement is correct? Définitivement, a molecule get larger multi, the speed of the molecule decreases multi. Bon, the piston remains in the same place. Ou bien the gas expand. Bon, écoutez, si on peut augmenter température, ça veut dire the pressure is proportional to temperature. Okay? Pressure is proportional to temperature. P over T est égal à constant. Si on augmente température, on augmente pressure. On augmente pressure, force is equal to pressure times area of piston reste pareil, ça la rheostat qui fait chini une certain pressure previously. Now the pressure has increased, définitivement, ça la rheostat pour plus grand et sa puissance là pour move dans la direction là, et le move dans la direction là, le gas expands. 32. The diagram shows a cross-section through a rainwater puddle formed in a shallow depression in a road surface. Okay. Over a period of time, the air temperature, wind speed, and wind direction all remain constant. Okay. Air temperature, wind speed, and wind direction all remain constant. What happens to the rate of evaporation of water from the puddle? Okay. Rate of evaporation, écoute bien, ça veut dire là, maintenant, ça surface area là. OK? Maintenant, ça molécule là énergétique. OK? Et voilà. Quand il finit à aller, moi exagéré. Il dit comme ça, à ce niveau comme ça. Ça surface area là, il diminue. OK? Ça veut dire, on a less molécules énergétiques à la surface. Ça veut dire, ici pour aller. Tout pour aller. Mais seulement the surface area peut decrease. Du moment que the surface area decrease, the rate of evaporation will. Est-ce qu'il est pour decrease? Est-ce qu'il est pour decrease? Et nous réfléchissons un coup là. Bon, là, il est facile de faire rien. Hein? Et parce que the surface area peut decrease. Si on me montre les autres là, hein? The surface area peut decrease. Temperature is constant. Air is wind speed is constant. Wind direction is constant. Okay? So is constant. The surface area will decrease. Ça veut dire the rate of evaporation will decrease. Larger surface area, larger high energetic molecule. Smaller surface area, smaller and less high energetic molecule. Ça veut dire là, pour moi, il n'est pas capable d'increase. Il n'est pas capable de remain constant, il est besoin de decrease. A student is investigating the evaporation of water. The student can change the depth of the water, the surface area of the water, the temperature of the water. How many of these changes, if any, would alter the rate at which evaporation occurs? Okay, depth, définitivement. No? Surface area, oui. Temperature also, yes. Ça veut dire tout. The table shows the increase in length of four metals when heated to the same temperature. Each metal initially has the same length. Okay. Aluminium, il augmente plus. Copper, moins. Platinum, moins. Et ça là, troisième. Ça veut dire ça là, increase more, nous allons dire à premier, à deuxième, à troisième, à quatrième, en termes d'expansion. Et bimetallic strip, bon, il n'est pas conscient de kinetic theory of matter, mais nous faisons additionnement. Hein? A bimetallic strip is made from two metals. When heated, it bends in the direction shown. Okay? Up here, metal X will expand more than metal Y. Bon, metal X est capable d'aluminium. Metal Y est capable platinium. Définitivement. Est-ce que metal X, copper, non, aluminium, non, steel. Steel, so expansion less than copper, non. Platinum, so expansion est less than steel, ça aussi, non. Ça veut dire, ah, c'est la bonne réponse. Et comment nous pouvons ça? Nous pouvons get sa length là, the outer diameter of sa arc là, les plis par arc, sa strip là, et les greater than the inner diameter. OK, ça veut dire ça metal X peut expand more than the metal Y. A liquid is heated. Which statement is incorrect? The molecule expand. The molecule gain energy. Shall we? The molecule move further apart. The molecule move faster. Oui. Et the molecule move further apart. Est-ce qu'un liquide in a expansion? Okay. And liquid in a expansion. Et nous disons yes. Nous chauffons d'affaires, mais pas pour moi. Et si nous prenons, oui, 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 the molecule will expand, move further apart, yes, mais the molecule pas qu'à expand, the molecule itself pas qu'à expand. The distance between the molecule capable expand, car increases, but the molecule itself, c'est-à-dire si on a une molécule, on a un atome de hydrogène et deux atomes d'oxygène comme ça, et sa molécule-là pas capable d'expandre. OK? Comment on mais si on a une molécule là et une molécule là, mon et définitivement, nous avons droit à une distance avec plus. OK? Et là, nous pouvons dire que the liquid has expanded. Pareil que moi solide. Numéro 36. What describe the molecular structure of a liquid? Distance between the molecules that are close together. Motion of the molecule random. Strength between the molecules fairly strong. Okay. B. Which of the following correctly compares the forces between the molecule in steam, water, and ice? The forces between the molecules. Weakest force, the steam. Après steam, you bring water. After water, you bring ice. Okay. The forces, attractive forces, increases in this the side direction. It is again the weakest force, strongest force. Solid are the most attractive forces. Some of the more energetic molecules in a liquid leave the surface, leaving the rest of the liquid slightly cooler. What is the name? Evaporation. A substance consists of particles that are close together and are moving past each other at random. The average speed of the particles is gradually increases. What best describes the substance? Average of the particles. A liquid being heated. They are close together, they are moving past each other. Yes, they are not vibrating, they are not moving at high speed separately. Okay, can liquid being heated. What is the property of both liquid and gases? They always fill the containers, no. They are incompressible, no. They can flow, oui. Both can flow. What conditions of the temperature? We are not in fixed position. What conditions of temperature and surface area would produce the most rapid evaporation from a pool of water on the world surface? Temperature high, surface area large. 42. Which factors increase the rate of evaporation of a liquid? Okay, nous avons increase the temperature. Nous avons increase the surface area. Ça là, okay, behavior. What will not affect the rate of evaporation from the surface of the liquid? Depth of the liquid. Draughts above the surface of the liquid. Surface area of the liquid. Temperature of the liquid. Bon. Draught, c'est quoi? Draught, c'est quoi? Et on appelle ça. Il est sec, comment dire? Water vapor in the air, ok? C'est facile pour water là escape dans l'air, ok? Si l'air c'est saturé avec water vapor, pas de problème evaporation, ok? Ça veut dire là, nous pouvons dire, ça veut dire tout ça là, il est correct. Cela will affect the depth of the liquid will not affect. 44, a substance consists of particles that are close together and are moving past each other at random. The average speed of the liquid gradually increases. What a liquid being heated? A student has 3 sealed plastic bags. One bag is full of gas, one of liquid, and one of solid. The student squeezes each bag to see if it changes shape and warms each bag to see if it expands. Okay. Which bag contains gas? The one that changes shape easily and expands the least when heated? No. If we expand the most, the one that changes shape easily and expands the most when heated. Ah, oui. It's fixed in shape. Ah, non, that is solid. Fixed in shape and expand the most when needed. Ça aussi, non. The one that changes shape easily and expand the most when needed. B. B, c'est la réponse. Ça, bague-là contain gas. A swimmer climbs out of a swimming pool on a warm day. Almost immediately, he begins to feel cold. Why is this? Then he climbs out of a warm swimming pool by day. On va check qui peut arriver. Et the water on the skin will evaporate. The water on the skin will evaporate. Quand il will evaporate, it will take energy from the body. And the person will have less internal energy and il will feel cold. Et nous avons il veut dire the water allows a convection current to remove heat from the skin. No. The water takes latent heat from his body in order to evaporate. Ah oui? Ah oui? The water on his skin is a good con. No. The water prevents infrared radiation from reaching the body. No. OK. Et là, comme on termine, moi arrête la vidéo et m'arrête de share d'abord. Et moi, j'espère que je ne comprends any problème. Fais-moi connaître, pour un commentaire et je vous répondre au plus vite possible. Je vous dis au revoir et à la prochaine vidéo.